Hi guys, this is a little bit of an overview of the review for Unit 1. Oops, let me just move that right there. My plan is to do a couple of questions with you, and then the rest you can work on your own, whether it's in class with me if you happen to be in class that day or at home. Some basic stuff that you definitely need to know about with functions. You need to know that for it to be a function, passes the vertical line test, which is the same as no repeating x values. For it to be one-to-one, it's got to pass vertical and horizontal, so no repeating x's or y's. Onto means every element, right, in the input and the output are mapped to something. The end behavior always starts as x goes to infinity, y goes to what, and you have to be able to fill in that blank. And same thing, where x goes to negative infinity. X-intercepts, y-intercepts should be pretty straightforward. Where the function is increasing, decreasing, or constant, right? The key with this is you have to read the graph from left. So I'm going to say read the graph from left to right, so that if it's increasing, it should be going up as you go to the right. If it's decreasing, it should be going down as you go to the right. And then if it's constant, it's going to be a flat horizontal line. All right. That's what you're looking at there. So I'm not sure if that made it into any earlier video, so it's good to take note of right now. Your notations, inequality set interval. Make sure you know which one is which. That will kill you in points if you don't know the difference, and then you get nitpicked for all those different little things. As for domain, the restricted domains, we'll do some practice with these. If the denominator is not equal to 0, the denominator should not be equal to 0 when you have a rational function. And then if it's a radical, the radicand, or the value underneath here, has to be greater than or equal to 0. Last parts, excuse me. Whew. All right. Good thing we're not in person, huh? The next thing, composition of functions. So you're plugging one function into the other. Sometimes I'm just going to give you a value of x, like 5 to plug in, and then you'll evaluate. Sometimes you'll be writing the new equation because you'll keep an x in there. And then the last thing, the inverse. If to find an inverse, the key, switch your x and y values and then resolve. Or if you're evaluating for an inverse, just remember that to plug in a value into the inverse is the same as setting the original equal to that value. So it's the same as it being the y value on the original function. All right, I've circled a few that I want to do in the video, so I'm going to rip through those right now. All right, so the very first one here, actually, let me see if I can find a happy medium. Ooh, there we go. The first one saying use the graph of f of x, so that's this over here, to answer the question. So state the y-intercept, all right? Y-intercept. Assuming every little value there is just 1, the y-intercept should then be 0, 2. Please make sure you write it as a coordinate point. The x-intercept, so it's crossing over here and over here. So this is at negative 1, 2, 3, 4, 5, 6. So that means negative 6, 0. And it's also crossing at 1, 2, 3, 4. So those are your x-intercepts. All right, over the interval from negative 1 to 2. So negative 1's right here to 2. Is the function increasing or decreasing? So go from left to right. From left to right, the whole time it is going up. So it is increasing. And then when it's saying, how can you tell? You could literally say from left to right, the value is going up, all right? Or the y value, the slope is up to the right, something along those lines, all right? Part D, state the domain and range of the function using inequality set and interval notation. I did not leave a ton of space here. Guys, you can always do your work somewhere else. I'm just going to do one of these, and since interval is my favorite, that's the one I'm going to write. So if I look, this goes all the way to negative 8, and yes, you can assume there's an endpoint there, and then up to positive 6. So that's my domain, because domain, I'm looking left to right. So my domain goes from negative 8 to positive 6, whereas the range, find the lowest point on the graph and the highest point. This is the lowest point of the graph. So that comes down to negative 1, 2, 3, 4. And then there's the highest point. That is at 2, 3, 4, 5, 6, 7, 8 right there. So it goes from negative 4 to 8. So make sure left to right, bottom to top. I know that's not high tech, but that's how you need to look at it. So here to here, here to here. Okay. Evaluate f of 1 and f of 5. So you're just simply going to those x values and looking at what is the corresponding y value. So at 1, the y value is 1, 2, 3, 4, 5. And if we go over to f of 5, the y value is -2. All right, is it a function? Well, we want to be looking at, does it pass the vertical line test everywhere? Yes. So we can say, yes, it passes the vertical line test. Is it a one-to-one function? No, it fails the horizontal line test in many places. So we would say no, because it fails, which means there's repeated y values. All right. The last part, evaluate f of -2. So you have to start with f of -2. So at -2, it kicks out a +2. And then we take and plug that in. So now go over to f of +2, and it kicks out 1, 2, 3, 4, 5, 6, 7, 8. So the final answer for that, so f of -2 is equal to 8. All right, hope that helps with the first one. Next one I want to look at is actually number 2. So when we come on over to number 2 here, it says consider the function absolute value of x minus 1 minus 8 defined over the domain just from -4 to 7. You can absolutely put that into your calculator. Right? So let me grab, where's my calculator? There we go. All right. And so when we look at this, let me get rid of whatever I have in there. I can go up to the math. Oh, goodness gracious. Math, absolute value, and then x minus 1, and then outside of that, -8. All right. Now, if you want, you can just go to Zoom 6, and that's perfectly fine. And you'll see a basic idea of what's going on. But if you are given a specific domain, then you're going to have endpoints and not arrows at the end of your graph. So you're only graphing from -4 to 7. So when you go over here, maybe you use the table of values specifically. And so you plot those exact points, right? I know you can only see my graph or my calculator so well, but so do it on your calculator at the same time. So here's -2. I'm just kind of labeling some things. So at -4, you're at -1, 2, 3. And then this looks like it's going to hit bottom here over at 1, -8. So -1, 2, 3, 4, 5, 6, 7, 8. And then it starts kind of coming back up. So you don't have to plot every point, but plot a couple points. So at 7 is the other end of it. So 2, 4, 6. So here's 7. It comes back up to -2. Right? And then if you happen to have a straight edge, that would make it look awfully lovely. Right? So we should have something like this. And then over here. All right. So that's the function specifically between -4 and 7. So you see that V shape, it's just a certain chunk of it. So it says make the table. All right, well, I got a little lazy, but you could see my table of values. So just make sure that you plot, some exact points. We shouldn't be kind of like estimating things. So it was -4, -3. I plotted, excuse me, specifically 1, -8, and then 7, -2. All right, state the x-intercepts. Well, if this graph had an unrestricted domain, you'd have 2 x-intercepts, but over that particular domain, there are none, and that's okay. So you can either say none, you can do like a little empty set. There's a lot of different ways you can do it. The y-intercept, it does have a y-intercept. It crosses right here at 0, -7. State the range of values over that given domain. So remember, the range means I'm going bottom to top. So the lowest value is happening down here at -8. The highest value is actually that top right corner, and that's happening at y equaling -2. So it literally sits between those two values right there. All right. Evaluate h of 4. H of 4 drops right here on our graph. So that's at -1, 2, 3, 4, 5. And then is the graph of h of x over the given domain a function? So for the part that you drew, is it a function? Yes, absolutely. right? And then the justification, because there's no like algebraic work, just explain it. So justification is that it would pass the vertical line test, right? So you can't just write yes. If it says justify, have some description as to why or some work as to why. How can we restrict the domain even further to make it a one-to-one function? All right, well, keep in mind, for it to be one-to-one, it needs to pass the horizontal line test. And right now, it would fail. So it's just saying, how could we restrict the domain? There is not one set answer. But if we remove part of the graph, could we remove a part so that when you draw a horizontal line, it would only hit once? Yeah. So maybe you remove the left-hand side, and so you only have this side of the V. In that case, I could restrict the domain to going from 1 to 7. So I could make the domain 1 to 7. So as an example, all right, I could make it from -4 to 1. But when it's saying how can you restrict it to make it 1 to 1, the idea basically is you would need to restrict the domain so that it passes the horizontal line test. So this would be an example of how we could restrict it, right? Number 3, I'm not going to do with you because there is no one set answer, but this one tends to throw people a little bit. It says draw a graph of f of x that matches the following characteristics. The domain has to go from -2 to 5. The range has to go from -4 to 6, and it has to have that x-intercept. So what I would suggest right now is label your graph. Label -2 and 5 on your x-axis. So 1, 2, 3, 4, 5. And then your range, label where -4 is and where +6 is. All right, and then the one thing it does specify is you have to have an x-intercept at 1, 0. So 1, 0. So what you've essentially done, and I happen to have a highlighter here, so I'm going to use my highlighter, is you've given yourself like a little window of the graph that your graph has to sit in. So it can't go any lower than -4. It can't go any higher than +6. It can't go further to the left than -2. It can't go further to the right than 5. So your entire graph needs to be able to sit within that little highlighted window, and it specifically has to pass through that point. The only other funky little catch is it has to be closed circles at the bottom and the top, right? And it has to be a closed circle at 5. It needs to specifically be an open circle at -2. Now, that does not mean it has to be an open circle at -2 on the x-axis. It could be here, an open circle. It could be down here, an open circle. But it needs to not be closed. From there, you have your discretion. So maybe in class, we'll draw one as an example, but that should be enough to get you started where you have to be able to fit those dynamics or those dimensions that are given here. And then from there, you have free range. The only thing I would say is for it to be a function, it still needs to pass the vertical line test. So don't get too crazy like scribbling back and forth or anything. All right, the next one that we're going to look at together is not number 4, so keep moving. That is number 7. Number 7 is asking you to find the inverse. That's what that notation means, F inverse, algebraically. So figured we'd do A together, and then you can work on B on your own. Remember, f of x just stands for y. So sub back in a y, and then we swap. That is the key step here. As soon as you flip-flop the x and the y, now your goal is to get y alone. So I'm going to subtract 2 over to the left-hand side, divide everything by 5, and so I get x minus 2 over 5. You could split it and make it 1/5 x minus 2/5, but there's really no need to. I would just finish it with relabeling it as the inverse. And there you go. I think I had one last one that I wanted to look at with you. Let me see where, oh, here it is. And that is number 9. So last one here with number 9. Keep in mind, number 8, notice how it's crossed off. That's code for you guys. Don't have to do it. All right, so just skip that. For number 9, find the domain of the following functions, saying use your calculator to graph them. Sometimes it helps to see it graphically to know. And then give your answer using the notation stated. The day that we talked about restricted domains, There are a bunch of functions that are unrestricted. So don't go making up restrictions if there aren't one. All right. So for part A, when you see f of x equals half of x plus 9, this, if I graph it, is just a plain old line. All right. So if I graph this guy, we'd look, something like this. It's going to extend forever, which means there are no restrictions on the domain. So in interval notation, the domain would go from negative infinity to positive infinity. For part B, if I graph this guy, this is actually a hyperbola, which your calculator would show you. But what I want you to take note of is it's a rational function where there's an x in the denominator, all right? Back here, yeah, you had a fraction, but there was no x in the denominator. That's why it doesn't count. So if there's an x in the denominator, the goal is that the denominator cannot be equal to 0. So if I actually take that denominator, which happens to be x itself, and I set it equal to 0, I have to remove that from the domain, right? So when you think of the domain, it can be anything bigger than 0, anything less than 0. It just can't be 0 itself. So in inequality notation, we would write the domain as x is less than 0 or x is greater than 0. That's what you're looking at. Right? For part C, so this was A, this was B, part C, you've got g of x equals the square root of 3x plus 1. When you have a radical function, you can only take the square root of numbers that are either 0 or positive numbers, so greater than 0. So you would take the expression underneath, set it to be greater than or equal to 0, and solve it. So when you rearrange, you would get x is greater than or equal to negative 1/3. Those are the values that you have to have. So I don't have to remove those from the domain. That just is the domain right there. So in set notation, you just got to fancy it up to say x such that x is greater than or equal to negative 1/3. So those should be the domains for the first 3. The rest you are on your own. All right. Hope that helps. We can ask more questions in class. As for the post-video question, I want to know what questions beyond those that you have questions about or that maybe you'd like to go over in class. So make sure to add that to your response in the post-video question.